Space is almost perfectly empty. In the gulf between the stars, you could travel a full kilometer and pass a single atom. We are taught this is why space is silent. With nothing to carry it, sound has nowhere to go. That explanation is correct, and it is incomplete. By the end of this video, you will understand what sound truly needs in order to travel, why the universe withholds it almost everywhere, and why almost is the most important word in that sentence. Start with the picture most of us carry without ever quite choosing it. Space, in the imagination, is the home of silence. Not the silence of a quiet room or a still field at night, but silence in its purest and most absolute form. A black, endless ocean where nothing stirs and nothing sounds. The image feels not merely plausible but obvious. Emptiness ought to be quiet. Where there is nothing, surely there is nothing to hear. It is one of those ideas the mind accepts so readily that it never thinks to examine it. And the strange thing is that the instinct is half right, in a way that turns out to be far more interesting than being simply correct. Space is indeed silent to us, almost everywhere, almost all of the time, but it is silent for a reason that has nothing to do with whether anything is happening. The universe is not still. It is one of the busiest places imaginable. Stars convert matter into light by the ton every second. Worlds wheel through their orbits at tens of kilometers a second, never slowing, never resting. Streams of charged particles pour out from suns and wash across whole planets. Fields of energy stretch and flex across distances that strain the very meaning of the word far. All of that is motion, ceaseless and immense. None of it, as a rule, is sound. Hold those two facts side by side, and a genuine puzzle appears. We tend to treat silence as evidence. A silent room is an empty room. A silent night is a still one. Quiet, in ordinary life, is simply the sound that nothing makes. So when we are told that space is silent, the mind quietly finishes the sentence on its own. Silent, therefore inactive. Quiet, therefore empty. Empty, therefore dead. The conclusion feels as though it arrives free, bundled in with the observation, demanding no further thought. It does not arrive free, and it is not correct. The silence of space and the ceaseless activity of space are not in tension at all, and seeing exactly why is the first real step of this whole investigation. Silence, it turns out, is not a statement about events. It is a statement about a medium, about whether there is anything present, anything physical, to carry a disturbance from the place where it happens to the place where you stand. Take that medium away, and the most violent event in the cosmos will reach you without so much as a whisper. Leave the medium in place, even thinly, even barely, and the faintest tremor imaginable can travel for a very long way indeed. That single distinction is very nearly the whole of it. It sounds almost too simple to carry so much weight, and that deceptive simplicity is exactly why it is so easy to get wrong. We do not usually have to think about the medium at all, because here on Earth it is always, unfailingly there. Air surrounds us from the moment we are born, pressing in at every point of the skin, filling every room and gap and lung. It is so reliably, invisibly present that we forget it is doing anything whatsoever. We speak and we are heard. We knock on a door and the knock carries down the hall. Sound feels like a property of the event itself, of the voice, of the knuckle striking the wood, rather than what it really is. A property of the air, doing its patient and unnoticed work of passing the disturbance along, hand to hand, molecule to molecule, all the way to the ear. If you find these reflective explorations of the cosmos meaningful, a like or a subscribe helps us continue making them. Pull the air away, and the event is entirely unchanged, but the hearing is gone. This is not a thought experiment invented to dramatize a point. It is something that has actually been done, carefully and deliberately, inside a sealed glass globe, and watching the sound die away inside that globe tells us very nearly everything we need to know about why the wider cosmos is so profoundly quiet. We will come to that experiment shortly, and to the restless 17th century mind who first performed it and understood what he was seeing. For now, hold on to the reframing, because every single thing that follows hangs from it. The question is not, why is nothing happening out in space? An enormous amount is happening, constantly, on a scale that dwarfs anything our planet has to offer. The real question is, why does all of that happening reach us in silence? And the moment the question is put that way, a second and sharper question follows close behind it. the one this whole investigation is really chasing. If silence depends on the absence of a medium, if space is quiet only because it is almost entirely empty, then what are we to make of the places where it is not quite empty enough? What about the regions where matter, however thinly, however reluctantly, still gathers in pools? Does the great silence hold there too? Or does something, in those rare places, come back? The honest answer, the one we will spend this entire investigation earning rather than simply asserting, is that something does come back. And what comes back is one of the most extraordinary discoveries in all of modern astronomy. There is a sound out there. It has been found, measured, and confirmed. It is not a metaphor, not a poetic flourish, not a clever way of describing a flicker of distant light. It is a genuine wave of pressure, moving through genuine matter, in exactly the way a sound wave moves through the air of this room, only on a scale so vast, and at a pitch so unfathomably low, that to call it a note almost insults how strange it truly is. But the wonder of that exception only lands if we have first felt the full weight of the rule. To understand why one sound in the darkness is so astonishing, we have to understand, properly and without shortcuts, why everywhere else is so silent. So begin with the rule, and begin with the small word that carries it: almost. Space is almost perfectly empty. Almost nothing lies between the stars. Almost no sound can cross those distances. That one word is doing a tremendous amount of quiet labor. It marks the difference between a universe that is truly, absolutely silent, a dead and featureless nothing, and the universe we actually inhabit, which is silent in the way a vast library is silent. Not because nothing is present, but because what is present has chosen, for the most part, a quieter way to make itself known. To feel the real force of almost, it helps to be precise about just how empty space is, and that precision is genuinely difficult to hold steady in the mind. This is not the tidy, modest emptiness of a cleared room, where the air still teems with molecules in their uncountable billions, jostling and colliding 1,000 million times a second. It is an emptiness many, many times deeper than that, so deep that the everyday word empty barely begins to reach it. And yet, crucially, it is still not nothing. There is a floor beneath which the universe does not fall, a thin and stubborn presence of matter scattered even through its loneliest and most desolate reaches. That faint presence will come to matter enormously before we are finished. It is the entire reason the silence is almost rather than absolute, and almost, as we will see again and again, is precisely where the whole story lives. There is always a temptation, faced with vastness like this, to reach for comfort, to soften the emptiness, to make it feel cozy and survivable and small. We will not do that here, because the truth is more interesting than the comfort could ever be. The emptiness of space is real, and it is severe. It is genuinely a place where you could shout with the whole force of your lungs and not stir the silence by the faintest measurable degree. But severity is not the same thing as lifelessness, and silence is not the same thing as stillness. The cosmos is not a quiet place, because nothing is happening within it. It is a quiet place because the one thing that carries sound is almost entirely absent, and because, in the rare and remarkable places where that one thing returns, the sound returns with it. That is the thread we will follow from here, outward from the simple, almost humble physics of a single vibration, through the silent machinery of stars and winds and wheeling worlds, all the way to the two places in the whole of creation where the universe grows loud enough, in the most literal and measurable sense, to be heard. But none of it makes sense, and none of it can be properly believed, until we have answered the most basic question of all, the one we have been quietly circling since the first sentence. Before we can understand why space withholds sound so completely, we have to understand exactly what sound is, what it requires, what it does, and why. In the absence of one specific thing, it simply cannot exist at all. That one specific thing is where we turn next. Sound is not a thing. That is the first surprise, and almost everything else follows from it. We talk about sound as though it were an object, something a voice produces, something that fills a room, something we can capture or store or shut out. But a sound is not an object at all. It is an event happening to a material. More precisely, it is a wave of pressure passing through a substance, and without that substance there is nothing for the wave to be. Begin with the source, because every sound begins with something moving. A plucked string flicks back and forth, a drum skin shudders, vocal cords vibrate, snapping open and shut hundreds of times a second. Whatever the source, it has the same effect on the air, immediately around it. As it moves outward, it shoves against the nearest air molecules, crowding them together into a thin shell of slightly higher pressure. As it swings back, it leaves behind a shell of slightly lower pressure, where the molecules are momentarily spread thinner than usual. Crowd, then thin. Compression, then rarefaction. The source does this again and again, and the result is a pattern of pressure rippling outward in every direction. Here is the part worth slowing down for, because it is the part our intuition gets wrong. The air molecules themselves do not travel across the room to your ear. Each one only jostles its immediate neighbors and then settles roughly back where it began. What travels is the pattern. A molecule crowds the one beside it, which crowds the one beside it, which crowds the next. And so the compression hands itself along, particle to particle, like a whisper passed down a line of people who each lean to murmur to the next, and then straighten up again. The message moves the length of the line. The people do not. Sound is that handoff, and nothing more, a disturbance carried forward by matter that mostly stays put. This is why sound needs a medium, and why the word medium is exactly the right one. A medium is the in-between, the connecting substance through which the handoff can pass. Air is a fine medium, which is why we hear so easily. But it is far from the only one, and looking at the others makes the principle unmistakable. In water, where the molecules are packed far more tightly and respond to one another far more readily, sound travels more than 4 times faster than it does in air, better than 1,400 meters every second, against roughly 340 in the air around us. In a solid such as steel, where the atoms are locked into a rigid lattice and pass a nudge along almost instantly, sound races faster still, at thousands of meters a second. The pattern is plain. The more closely and firmly the particles are coupled, the more efficiently they relay the disturbance, and the faster the sound. There is an old trick that makes this tangible. Press your ear to a metal railway line, and you can hear an approaching train through the steel well before the same sound reaches you through the air, because the rigid metal hands the vibration along so much more readily than the loose, drifting molecules of the atmosphere. Take the coupling away entirely, pull the particles so far apart that no molecule can reach the next to pass anything along, and the handoff has nowhere to go. The source can move all it likes. There is simply no line of neighbors to carry the message onward. That last idea sounds abstract, the kind of thing a physicist asserts and asks you to accept on trust. It is not. More than 3.5 centuries ago, someone built a machine specifically to take the medium away and watch what happened to the sound. His name was Robert Boyle, and the experiment he performed in 1660 is, in a quiet way, the foundation of everything this whole investigation is about. Boyle was an Irish-born natural philosopher working in Oxford, one of the sharpest and most careful minds of his generation, at the very dawn of what we would now recognize as experimental science. He had become fascinated by air, by the question of what air actually is and what it actually does, and to study it properly, he needed a way to remove it. So, working with a brilliant young assistant named Robert Hooke, who would go on to become a great scientist in his own right, Boyle had built one of the first effective air pumps in the world, a glass vessel, a receiver from which the air could be steadily drawn out, creating inside it something close to a vacuum. Nobody had ever had such reliable access to emptiness before. It was a doorway into a place that, until then, had been almost purely a matter of philosophical argument. Among the many things Boyle did with his new machine, one experiment matters most here. He took a small timepiece, a watch fitted with an alarm, a little striking bell, and he suspended it inside the glass receiver, hanging by a thread so that it touched the walls as little as possible. He set the alarm going, and at first, with the receiver still full of air, he could hear it clearly, the bell striking, the sound passing through the air, through the glass, and out to his ear exactly as expected. Then he began to pump. As the air was drawn out of the vessel, breath by breath of the machine, something remarkable and unsettling happened. The sound of the bell grew steadily fainter, not because the bell was striking any less forcefully. Through the glass he could still see it ringing, the little hammer beating away with undiminished vigor, but because there was less and less air inside to carry the sound to the wall of the vessel. The event continued, plain to the eye. The hearing of it drained away. By the time the receiver was as empty as his pump could make it, the ringing had fallen to almost nothing, a bell striking in near-perfect silence, visibly active and audibly gone. Boyle understood exactly what he was seeing, and he understood its importance. The motion of the bell had not changed at all. What had changed was the medium. Remove the air, and you remove sound's only means of travel. The vibration was still there, locked uselessly inside the source, unable to step out into a world that no longer offered it a path. He had not silenced the bell. He had silenced the space around the bell, and discovered that the two are not the same thing. It is worth pausing on how modern this was. Boyle was honest about the limits of his apparatus. His pump could never reach a perfect vacuum, and the thread the watch hung from could itself carry a faint tremor of sound to the glass. So the silence was never quite total. He noted these imperfections carefully rather than hiding them, which is part of why we still admire the work. But the conclusion was unshakable, and it has never been overturned. Sound requires a material medium. Strip the medium away, and the loudest source becomes silent, not because it has stopped, but because there is nothing left to listen with, nothing in between to carry the news of its motion outward. Sit with that, because it changes the meaning of the silence we are chasing. The quiet of space is not some special, exotic property of the heavens, some cosmic stillness that descends where the stars hang. It is the very same quiet Boyle conjured inside a glass jar in an Oxford room in the middle of the 17th century, the ordinary, lawful consequence of taking the air away. He made a tiny, fragile patch of vacuum, a thimbleful of emptiness, and inside it sound simply ceased to be possible. Space is that same emptiness, except that it is not a thimbleful and it is not fragile. It is the overwhelming condition of the entire universe, stretched across distances the human mind was never built to picture, and far emptier, in those reaches, than anything Boyle's pump could ever have achieved. And that is the thought that carries us onward. Boyle worked hard to make a small volume nearly empty, and even his best vacuum still held far more matter than the true desert between the stars. We say space is almost perfectly empty, but the words slide past too easily. We nod at them without feeling them. Before we go any further, before we follow the silence outward into the workings of stars and winds and worlds, we need to confront, as squarely as we can, just how empty that emptiness really is, how few particles actually inhabit the dark, and how impossibly far apart they lie. Only then does it become clear why the handoff that brings us every sound we have ever heard cannot, almost anywhere out there, even begin. So sound needs a crowd. It needs particles close enough together and colliding often enough to pass a disturbance from one to the next in an unbroken chain. The question, then, is brutally simple. How crowded is space? And the answer is so far outside ordinary experience that the only honest way to grasp it is to build up to it carefully, starting from something we can actually hold in the mind. Take a single cubic centimeter of the air in the room around you, a little box the size of a sugar cube. It feels like nothing. It weighs almost nothing. You move your hand through thousands of such boxes without noticing one of them. And yet that tiny volume of ordinary air contains something on the order of 25 billion molecules. Not millions, not billions, billions of billions, a number with 19 zeros after it, packed into a space you could balance on a fingertip. Those molecules are in a frenzy, hurtling about at the speed of a rifle bullet and colliding with one another billions of times every second. This is the medium that carries every sound you have ever heard. It is so dense, so relentlessly self-colliding, that a pressure wave passes through it with effortless ease, handed from molecule to molecule in a continuous, seamless relay. Sound on Earth is not a delicate achievement. It is almost impossible to prevent. Now carry that same little sugar cube box out beyond the atmosphere, past the orbits of the planets, into the open space between the stars, and fill it with whatever you find there. On average, across the typical reaches of our galaxy, you will have caught about one atom. One. A single, solitary atom, where a moment ago, there were 25 billion. That is the scale of the emptiness. It is not a little thinner than air, or 1,000 times thinner, or even 1,000,000 times thinner. It is something like 10 billion times thinner, a difference so vast that the word empty, worn smooth by everyday use, genuinely cannot carry it. Try to picture what that means for the atoms themselves. In the air, a molecule is forever bumping its neighbors, jostled and jostling, never alone for more than the briefest instant. In interstellar space, the atoms are strewn so thinly that they drift in near total isolation. An atom here, then perhaps a centimeter of nothing, then another atom, each one wandering through the dark on its own. And because atoms are unimaginably small targets, the chance of one actually striking another is correspondingly tiny. An atom in that desert can travel an enormous distance, in the thinnest regions, distances that beggar belief, before it happens to collide with anything at all. The frantic, ceaseless contact that lets air carry sound is simply gone. There is no crowd. There is barely a scattering. It is worth knowing what that lone atom usually is, because it grounds the emptiness in something real. More often than not, it is hydrogen, the simplest and oldest element there is, much of it forged in the first minutes after the universe began, and the rest cycled out across billions of years from the interiors of stars. This thin scattering of mostly hydrogen, drifting between the suns, is what astronomers call the interstellar medium. And medium, here, is almost a cruel joke, because it is precisely the kind of medium through which ordinary sound cannot pass. It is a gas in name only, too sparse to behave like the air we know, too stretched to relay a vibration. It can be lit up by nearby stars, sculpted into glowing clouds, pulled slowly together over ages to build new suns. What it cannot do, on any scale we could hear, is carry a sound. It helps to stretch the picture out to human scale, even knowing the stretch must fail. Imagine taking the contents of that single breath of air, those billions of molecules crammed into a few cubic centimeters, and spreading them out until they matched the emptiness of interstellar space. You would have to scatter them so widely that the few atoms left in any sugar cube volume would be separated by gulfs far larger than the room you are sitting in. Try to start a sound in such a place. Clap, shout, set off an explosion, and the disturbance reaches outward for its first neighbor and finds, where a neighbor should be, only distance. The chain breaks at the very first link. There is no second particle close enough, soon enough, to take the hand off. The motion stays trapped at its source, exactly as the ringing stayed trapped in Boyle's bell, and for exactly the same reason. And interstellar space, thin as it is not even the emptiest place there is. Drift out beyond the galaxies entirely, into the great voids that yawn between them, and the density falls further still, down towards something like a single atom in a whole cubic meter, a box you could stand inside, or even less than that. Out there, the matter is so sparse that calling it a gas feels generous. It is closer to a rumor of matter, a faint statistical haze, with light years of true nothing between one lonely atom and the next. There is a comparison that drives the point home with a certain humbling force. We have become very good, on Earth, at making vacuums, far better than Boyle ever was. The finest vacuum chambers ever built, the ones used in the most demanding laboratories and the most delicate experiments, can pump a volume down until only a tiny remnant of gas is left. And yet even those extraordinary engineered emptinesses, the best we can manufacture with all our modern skill, still hold far more matter, far more densely packed than the open space between the stars. We cannot make, on Earth, a vacuum as empty as the ordinary night sky. The desert out there is deeper than anything we know how to build. This is the thought to hold steady. Boyle labored to empty a single glass globe, and counted himself fortunate to drive out as much air as he did, and even his triumphant little patch of near vacuum was, by cosmic standards, a dense and crowded place. The universe does effortlessly, and on an unthinkable scale, what Boyle could only approximate in a jar. Almost the entire volume of the cosmos, the spaces between the planets, between the stars, between the galaxies, is emptier than the inside of his receiver by margins that make the comparison almost absurd. The universe is not a place that happens to contain some vacuum. The universe is a vacuum that happens to contain, here and there, the rare bright crumb of a star or a world. We live on one of those crumbs, inside a thin and precious skin of air, and from there we look out at an ocean of emptiness and call it, with quiet understatement, space. So the silence is explained, and explained completely, for the kind of sound we know. No clap, no voice, no explosion, no scream, no sound of any pitch a human throat could make or a human ear could catch, can cross those distances because the medium that would carry it has been stretched out of existence. The loudest event you can imagine, set off in the open between the stars, would unfold in total and permanent silence. Its motion, real but unshared, exactly as Boyle's bell rang silently inside its emptied glass. The rule is firm. Space, on the human scale of sound, cannot speak. And yet, And this is the turn the whole investigation now takes. That same silent, near-empty space is not still for a single instant. It is in furious, ceaseless, magnificent motion. The crumbs are not sitting quietly in the dark. Stars are wheeling around the centers of their galaxies at speeds that would carry them across a continent in a heartbeat. Worlds are racing along their orbits, held on their curved paths by a force that reaches across the emptiness without ever touching a thing. Whole galaxies are streaming through the cosmos, drawn and shaped by influences that cross the void as easily as the silence does. None of it makes a sound. All of it is happening anyway. If the absence of sound is not the absence of motion, then we are left with the obvious next question, the one that begins to show us how the universe really works. What is moving all of this? What carries across the emptiness, when sound so plainly cannot? The answer begins with the quietest and most powerful choreographer of all, the force that holds the wheeling worlds to their paths. The force that moves the worlds makes no sound, and it makes no contact either. This is the first strange thing about gravity, and it is easy to miss because gravity is so familiar that we stop noticing it entirely. It holds us to the ground, it pulls a dropped cup to the floor, and we treat it as a kind of background fact of existence. But out in space, gravity reveals its real nature, and that nature is quietly astonishing. It reaches across the emptiness that sound cannot cross. It needs no medium, no chain of particles, no crowd to pass itself along. It acts between bodies separated by tens of millions of kilometers of near-perfect vacuum, and the vacuum does nothing to weaken it. Where sound dies at the first gap, gravity simply does not care that the gap is there. Consider what that means for a single planet. The Earth is held to the Sun across roughly 150 million kilometers of empty space, a distance so great that the Sun's light, moving at the fastest speed there is, takes more than 8 minutes to cross it. Through all that emptiness, with not one continuous thread of matter connecting the two, the Sun holds the Earth fast. Nothing reaches out and grips it. No rope, no rod, no pressure of any substance pushes or pulls, and yet the Earth is bound as surely as if it were chained, swinging around its star year after year, never flying off into the dark, never falling in. A force is plainly at work, and it is working through a void in which sound would be struck instantly dumb. The deepest understanding of what an orbit really is came from Isaac Newton, and it remains one of the most beautiful ideas in all of science. An orbiting world, Newton saw, is not being held up by anything. It is falling. The Earth is falling toward the Sun continuously, pulled inward exactly as a dropped stone is pulled toward the ground. But the Earth is also moving sideways, very fast, and so as it falls toward the Sun, it is forever sweeping past it, missing it, the inward pull and the sideways rush combining into a great curved path that closes on itself. An orbit is a perpetual fall that never lands, a plunge bent endlessly into a loop by the body's own forward motion. The moon falls around the Earth in just the same way. The same force that brings an apple down from a branch reaches out nearly 400,000 kilometers and holds the moon on its leash. Newton understood that these were not two different things, but one, the same silent law governing the fall of the smallest object and the wheeling of the largest. There is a way to feel this directly, even from the ground. The astronauts who circle the Earth, drifting weightless through their cabins, are not floating because they have escaped gravity. Gravity is nearly as strong where they are as it is at the surface. They are weightless because they, and their spacecraft, are falling continuously around the planet, fast enough sideways that they keep missing it, exactly as the Earth keeps missing the Sunday. The serene, untroubled drift of a body in orbit is, underneath, a headlong and never-ending plunge. Nothing about it is restful in the way it looks. It only appears calm because the fall is shared by everything in sight, and because, in the vacuum it happens in, the plunge makes no sound at all. And the speeds at which all this falling happens are difficult to credit. The Earth is not drifting gently around the Sunday. It is racing along its orbit at about 30 kilometers every second, 30 times faster than a high-velocity rifle bullet, fast enough to cross the whole width of a country in the time it takes to read this sentence. We feel none of it. There is no wind of our passage, no sense of speed, no sound of the air rushing by, because there is no air out there to rush, nothing for our headlong motion to push against and set roaring. We are traveling at a speed that would be unsurvivable on any road, and the journey is utterly, perfectly silent. The closer worlds move faster still, whipping around the Sun in tighter, quicker loops. The distant ones move more slowly, tracing immense and stately circles that take decades or centuries to complete. Every one of them, fast or slow, near or far, moves in the same total quiet. The solar system is a machine of enormous moving parts, and not one of them makes a single sound. It is tempting to reach for the old image of a cosmic dance, a choreography set to some unheard music, but the truth is more precise, and, in its way, more impressive than any dance. There is no music and no choreographer. There is only a balance, a standoff between two simple tendencies. Left alone, a planet's own momentum would carry it in a straight line, off into the dark forever. Left alone, the sun's gravity would draw it straight into a fiery end. Neither happens, because the two are matched. The forward rush and the inward pull hold each other in a permanent, self-sustaining truce, and out of that truce comes the closed and stable path we call an orbit. Nothing is being actively steered. No effort is being spent. The arrangement persists, for the simplest of reasons. It is the shape that balance takes, and once found, it can hold for billions of years, without adjustment. That is why the solar system behaves like a clock that keeps time without ever ticking. The planets return to their places with such reliability that astronomers can predict, centuries in advance, the exact moment a shadow will fall across a particular town, the precise night a planet will stand in a particular spot among the stars. Eclipses can be foretold for 1,000 years ahead and 1,000 years past. The whole vast mechanism runs on, lap after lap, with a regularity that puts every human-made clock to shame, and it does it in silence, because the precision lives in the motion itself, not in any sound the motion makes. We are used to machinery announcing itself, to gears that grind and engines that hum. This is machinery that has thrown all that away and kept only the timekeeping, and gravity does not stop at moving the worlds about. The same silent force builds and holds together nearly everything in the sky. It is gravity that gathered the scattered gas of the early universe into the first stars. Gravity that squeezes a star's matter inward, hard enough to set its core alight. Gravity that binds hundreds of billions of stars into the slow, wheeling disk of a galaxy. It shapes the largest structures in existence and the smallest fall of a pebble, all by the same wordless rule, all without a flicker of sound. The most powerful organizing principle in the cosmos is also among the most utterly quiet. It works the way the silence works, everywhere at once, across any distance, asking for nothing and announcing nothing. So we have our first real answer to the puzzle of a silent universe in furious motion. The motion is being driven by something that has no need of sound and no relationship to it. A force that crosses the very emptiness that strangles every vibration and moves the worlds about as if the emptiness were not there at all. Activity and silence are not in conflict. They never were. The activity is simply being carried by a different messenger than the one our ears are tuned to. But gravity, for all its reach, is only the choreographer. It arranges the bodies and sets their paths. It does not, itself, blaze or burn. The bodies it moves, the stars, are something else again. Each one is a furnace of a violence almost beyond description, converting matter into raw energy by the millions of tons every second, pouring out enough light to be seen across the entire galaxy. If anything in the universe ought to roar, surely it is a star. Here, if anywhere, the silence should break. And so the next place to look is straight into that furnace, to ask how an object of such terrible power can do its work, like everything else out here, without making a sound. Look into the heart of a star, and you are looking at the most concentrated violence in the universe outside of its rarest catastrophes. At the center of the sun, the temperature reaches some 15 million degrees, and the pressure is greater than anything human beings will ever manufacture. Under that crushing weight, the nuclei of hydrogen atoms, ordinarily flung apart by their mutual repulsion, are forced so close together that they fuse, merging into helium. And here the crucial thing happens. The helium that emerges weighs very slightly less than the hydrogen that went into making it. That missing sliver of mass has not vanished. It has been converted, wholesale, into energy, in accordance with the most famous relationship in physics, the recognition that mass and energy are two forms of the same thing, and that even a trace of mass, released, becomes a flood of energy. The amount of matter the sun converts this way is almost impossible to take in. Every second, deep in its core, the sun turns around 4 million tons of itself into pure energy. Not 4 million tons of fuel burned in the ordinary sense. 4 million tons of actual substance erased from existence as matter and reborn as radiation. every single second, and it has been doing this for billions of years, and will go on doing it for billions more. The energy released each second dwarfs the entire output of human civilization across its whole history. By any reckoning we are used to, this is the loudest possible thing, a detonation beyond all detonations, sustained without pause at the center of our sky. The idea that stars run on this hidden energy locked inside matter was itself hard-won. Early in the 20th century, the astronomer Arthur Eddington argued that the sun must be powered by the fusion of hydrogen in its depths, that the subatomic energy of matter itself was the only source deep enough to keep a star burning for the immense ages the rocks of the Earth demanded. He was met with doubt. Some insisted the interior of the sun was not hot enough for such a thing. Eddington's reply has become famous. He suggested the doubters go and find a hotter place. He was right, and the working out of exactly how the nuclei combine, step by step, would occupy some of the finest minds of the century. The furnace was real and far stranger than burning. Yet for all that fury, a star does not blow itself apart, and the reason returns us to a familiar idea: balance. The same gravity that lit the core in the first place is forever trying to crush the star inward, to collapse it under its own colossal weight. The energy pouring out from the fusion pushes the other way, outward, holding the collapse at bay. These two titanic tendencies, the inward crush of gravity and the outward push of released energy, settle against each other in an almost perfect equilibrium, and the star sits poised between them, neither collapsing nor flying apart, for age upon age. It is the same kind of standoff that holds a planet in its orbit, scaled up to govern an entire sun. A star is not a bomb going off. It is a bomb held, every instant, in a grip exactly strong enough to contain it. The violence is total and totally controlled. Now, ask the question this whole investigation keeps asking. All of that, the 15 million degree core, the 4 million tons a second, the unending controlled detonation, how much of it do we hear? Nothing, not the faintest murmur. The sun is the most powerful object most of us will ever encounter, and it reaches us in perfect silence, because around the sun, as around everything, lies the vacuum. The fury is real, but it has no medium to shout into. The most violent engine in our corner of the cosmos runs behind a wall of emptiness that no sound can climb. And there is something even stranger about how the sun's energy reaches us, something that deepens the silence rather than breaking it. You might imagine that the energy made in the core races straight out and flies off into space at once. It does nothing of the kind. The interior of the sun is so dense, so packed, that a particle of light born in the core cannot travel any distance at all before it is absorbed by the matter around it, then re-emitted in some random direction, then absorbed again, then re-emitted again, over and over, billions upon billions of times. It is a staggering, drunkard's walk through the body of the star, a journey of relentless stop and start in which the energy stumbles outward by the tiniest steps. By most estimates, the energy now leaving the sun's surface as sunlight was made in its core, not minutes or years ago, but tens of thousands of years in the past. It has spent all that time fighting its way out through the crush. The light that warms your face today began its journey before the last ice age ended. And only at the very surface, after that immense and ancient struggle, does it finally break free into the vacuum and cross the last 150 million kilometers to Earth in a little over 8 minutes of silent flight. The fusion in the core throws off one other thing, and its behavior could not be more different. Alongside the light, each reaction produces ghostly particles called neutrinos, and neutrinos barely notice ordinary matter at all. Where a particle of light is trapped for tens of thousands of years, fighting its way out step by tiny step, a neutrino slips straight through the entire bulk of the sun as though it were not there, escaping the core in a couple of seconds and reaching the Earth in those same 8 minutes, direct, unhindered, almost untouchable. Trillions of them are passing through your body as you read this, fresh from the center of the sun, and you feel nothing, because they interact with you about as readily as they interact with the vacuum. The core speaks to us in two voices at once: light that is ancient by the time it arrives, and neutrinos that are only minutes old. Neither voice is sound, but here is the detail that points, quietly, toward everything still to come, the first faint crack in the rule. Inside the sun, where the matter is crushed to such density, sound is not impossible at all. On the contrary, the sun is full of sound. Pressure waves, true sound waves, of exactly the kind Boyle's bell could not make in a vacuum, ripple constantly through the dense gas of the solar interior, set off by the churning turmoil beneath the surface. They travel down into the star, bend, and come back up, ringing through the whole vast body of it. The sun, in a real and measurable sense, hums. It rings like an enormous bell, struck endlessly from within, vibrating with a chord of countless overlapping tones. And astronomers have learned to read those vibrations in the trembling of the sun's surface, using them to map the hidden interior they could never otherwise see, a whole science built on listening, in effect, to the sun's internal sound. So why is the sun silent to us, if it is so full of sound within? For the one reason that governs everything out here: the sound is trapped. It lives in the dense interior, where there is matter enough to carry it, and at the surface it reaches the edge of that matter and can go no further. Beyond the surface lies the vacuum, the great insulator, and the ringing simply stops at the boundary, sealed inside the star like the ringing sealed inside Boyle's glass. The sun is an island of density, adrift in an ocean of emptiness, and its sounds, however real, cannot swim across to us. They reach the shore of the star and fall silent. Hold on to that image, because it is the shape of the answer this whole investigation is moving toward. Sound is not forbidden in the universe. It is forbidden only where matter is too thin to carry it, which is to say, almost everywhere. But wherever matter does gather thickly enough, in the heart of a star, sound returns, exactly as the physics says it must. The stars themselves are quiet to us, not because they cannot make sound, but because they make it on the inside, behind walls of vacuum, where no ear can follow. The silence is a fact about the emptiness between things, never about the things themselves. That is the star seen whole, from a distance, as a furnace and a bell sealed in the dark. But our own star is near enough to study in extraordinary detail, near enough to watch its surface seethe and storm and turn, near enough to see the great arcs of matter it flings off into space. If the calm point of light in our daytime sky is in truth a churning, restless, violent thing, then bringing our attention close to its surface should show us power and turmoil on a scale that would deafen us, if only the emptiness allowed. So that is where we go next, down to the surface of the sun, to watch the storms break in silence. The sun we glance at looks like the simplest thing in the sky, a smooth, flat, featureless disk, too bright to study, seemingly unchanging from one day to the next. It is an illusion produced entirely by distance. Bring the surface close, as our telescopes and solar spacecraft now can, and the calm disk dissolves into a scene of staggering turmoil, a churning, boiling, restless skin of plasma in ceaseless, violent motion, never the same from one minute to the next. The stillness was only ever a trick of being far away. The first thing the close view reveals is that the surface is boiling, in a way not so different in principle from a pot of water on a stove, only on a scale that defies comparison. Hot plasma rises from below, spreads out across the surface, cools, and sinks back down, and this overturning breaks the whole face of the sun into a mosaic of bright cells called granules. Each granule is a single rising column of hot material, and each one is roughly 1,000 kilometers across, the size of a sizable country, appearing and bursting and vanishing within mere minutes before the next takes its place. The entire visible surface of the sun is paved, edge to edge, with these brilliant, short-lived cells, a fizzing, seething carpet of country-sized bubbles, forever rising and breaking. It is this colossal churning, this endless convective boil, that strikes the great bell of the sun from within, and sets the internal sound waves ringing through its depths. The boiling we can see is the hammer. The trapped sound we cannot hear is the note. Against that bright seething, darker marks come and go, the sunspots, cooler islands on the burning surface, each one often larger than the entire Earth, some of them several times wider than our whole planet. They look dark only by contrast. In truth, they are merely 1,000 degrees or more cooler than the blazing material around them, dimmer rather than dark. People have watched these spots crawl across the sun's face since the very first telescopes were turned skyward 4 centuries ago, Galileo among them, tracking the spots night after night and realizing, from their slow procession, that the sun itself must be turning. The spots are not blemishes. They are the visible footprints of something invisible and immensely powerful. The sun's magnetic field, breaking through the surface and choking off the boil beneath. For the sun is a magnetic body, and its magnetism is the source of nearly all its drama. Because the sun is not solid but fluid, it does not rotate all of a piece, Its equator spins faster than its higher latitudes, and over time this uneven rotation winds the magnetic field around the body of the star, stretching and twisting it, tangling it into knots of stored tension like a rubber band wound tighter and tighter. Where those tangled field lines pierce the surface, they suppress the rising heat and a sunspot forms. And where the strain finally becomes too great, the tangled field snaps and rearranges itself, and the stored energy is released all at once. When that release happens, it is called a solar flare, and it is one of the most powerful events in the solar system. In a span of minutes, a flare can unleash an amount of energy that beggars description, the equivalent of many millions of the largest weapons humanity has ever built, detonated together in a single brilliant flash of radiation that brightens a patch of the sun across the whole spectrum of light. Often the flare is accompanied by something even more massive, a coronal mass ejection, a vast bubble of magnetized plasma, billions upon billions of tons of solar material, torn from the sun and flung bodily into space at speeds of hundreds, sometimes thousands, of kilometers a second. A single such eruption hurls more matter than a mountain range out across the solar system. And now hold all of that against the question we keep returning to. A solar flare is, very nearly, the loudest event imaginable, an explosion that could swallow many Earths whole, releasing in minutes more energy than our entire species has used in its existence. If it happened in air, the sound would not merely be heard, it would be an apocalypse of sound, a blast to flatten worlds. It happens in vacuum, and so it happens in perfect, absolute silence. The flash of light reaches us in 8 minutes. The cloud of plasma sweeps past in a day or two, and from first to last, this titanic eruption makes no sound at all, because there is no medium around the sun to carry one. We have learned to watch these eruptions with instruments, to see them flare and bloom and reach out toward us. But we have never heard one, and we never will, any more than Boyle could hear his bell once the air was gone. The grandest violence and the deepest silence, once again, turn out to be perfectly compatible. This storminess is not constant. It rises and falls in a long, steady rhythm, a magnetic season that turns over roughly every 11 years. At one part of the cycle, the sun grows restless and spotted and prone to flares. At another, it falls quiet, its face nearly clear, its eruptions rare. And at the peak of each cycle, something remarkable happens. The entire magnetic field of the sun reverses, north and south trading places, the whole star turning its magnetism inside out, before slowly winding up again toward the next reversal. The sun breathes through these long magnetic seasons, on a timescale far slower than a human life is built to notice, decade folding into decade. And it does so, like everything else, without a sound to mark the turning. The rhythm itself was teased out only by patience, by observers counting sunspots, year upon year, across the better part of a lifetime, until the slow tide of the cycle finally showed itself in the numbers. The mightiest clock of weather in the solar system keeps its 11-year time in total quiet, and it gave up its rhythm only to those willing to watch it in silence for decades. What all of this reveals is a star that is anything but the placid lamp it appears to be. The sun is a churning, magnetic, explosive thing, boiling at its surface, nodding and snapping its vast magnetic field, hurling mountains of matter into the dark, and conducting the whole performance in a silence so complete that from Earth, it can be mistaken for serenity. The calm is real, but it is the calm of distance and of vacuum, not the calm of rest. Underneath, nothing rests at all, and the sun's restlessness does not end at its visible edge, where the flares bloom and the spots crawl. The eruptions are only the dramatic punctuation of something far more constant. Surrounding the whole churning star is its outermost atmosphere, the corona, a faint pearly halo of plasma that reaches far out beyond the visible surface, and which most of us only ever glimpse in the few precious seconds of a total eclipse, when the moon blocks the bright disk and the ghostly crown springs into view around it. The corona hides one of the great puzzles of solar physics. The visible surface of the sun sits at some 5,500 degrees. The corona floating above it is heated to millions of degrees, hundreds of times hotter than the surface beneath. That is the wrong way round, as strange as a kettle whose steam is far hotter than the water it rose from, and exactly how the corona is heated to such ferocious temperatures is still not fully settled. But the consequence is decisive. The corona is so blisteringly hot that the sun's gravity, vast as it is, cannot hold it down. The outermost reaches of that superheated atmosphere are forever boiling off the top of the star and streaming away into space. The sun, in other words, is leaking, continuously, in every direction, all the time. Its outermost atmosphere is so hot that it cannot be held down even by the star's enormous gravity, and so it streams perpetually outward into space, a ceaseless wind of particles blowing past the planets and out toward the edges of the solar system. For a long time, no one suspected this wind existed. When one man finally worked out that it must, and described it in detail, the established experts told him plainly that he was wrong. He was not wrong. And the story of how the solar wind was predicted, doubted, and then discovered is where we turn next. In the 1950s, the accepted picture of the space between the sun and the planets was of a calm and largely static place. The sun had an atmosphere, certainly, and that atmosphere was known to be strangely hot, but most scientists pictured it as essentially still, a hot envelope that thinned away gradually with distance and simply sat there, in quiet equilibrium, surrounding the star. Into this settled consensus came a young physicist at the University of Chicago named Eugene Parker, and he looked at the same hot corona and saw something nobody else had let themselves see. There had, in truth, been a clue hanging in the sky for centuries, had anyone known how to read it. When a comet swings near the sun and grows a tail, that tail does not trail behind the comet like smoke behind a train. It points away from the sun, always away, no matter which way the comet is traveling, as though something were forever blowing it back. In the early 1950s, the astronomer Ludwig Biermann studied this and concluded that something was. There had to be a continuous stream of particles pouring off the sun, steady enough and strong enough to push a comet's tail straight out behind it on the far side from the star. The comets had been flying their windsocks in the solar wind the whole time, marking the direction of a flow no one had yet named. Parker took that hint and the blazing temperature of the corona and built them into a complete and rigorous theory. Parker reasoned it through from the physics. If the corona was as hot as the measurements said, millions of degrees, reaching far out from the sun, then it could not possibly sit still. A gas that hot has so much energy of motion in it that no force available could hold it in place. The sun's gravity, immense as it is, was not strong enough to keep such a scorching atmosphere bound. The only possible outcome, Parker showed, was that the corona had to be expanding, flowing outward continuously, faster and faster as it went, accelerating until it was streaming away from the sun faster than sound could travel through it. Not a still atmosphere at all, but a perpetual outward gale, a steady wind of particles blowing off the sun in every direction and racing out across the entire solar system. He gave it a name that has stuck ever since: the solar wind. The reception was harsh. When Parker submitted his paper, laying out the idea, in 1958, the reviewers rejected it. The notion seemed to them simply wrong, at odds with everything the established authorities believed about the quiet corona. By the ordinary workings of science, the paper might have died there, but the editor of the journal happened to be one of the towering theoretical physicists of the century, Subrahmanyan Chandrasekhar, and when Chandrasekhar went through Parker's mathematics, he could find no error in it. The reasoning was sound, whatever the reviewer's instincts said. He overruled the rejections and published the paper. It was a quiet act of intellectual courage, and it turned out to be decisive, because Parker was right and nearly everyone else was wrong. The proof came just a few years later, and it came from a spacecraft. In 1962, on its long voyage toward Venus, the probe Mariner 2 carried instruments out into interplanetary space and measured what was actually there. It did not find a still and empty calm. It found exactly what Parker had described: a continuous, unbroken stream of charged particles flowing outward from the sun, never pausing, never letting up, blowing past the spacecraft the entire way. The solar wind was real. The young man whose paper had been rejected had correctly deduced, from pure physics, an entire ceaseless river of matter pouring out of our star before anyone had ever detected it. Consider what that wind actually is. It is made of the broken down pieces of atoms, mostly protons and electrons, the charged debris of the hydrogen that makes up so much of the sun, torn loose and flung outward at tremendous speed. The ordinary, steady wind blows past the Earth at something like 400 kilometers every second. The faster streams, pouring out of particular regions of the sun, can move at 700 kilometers a second or more. These are speeds that turn the distance from the sun to the Earth into a journey of just a few days. And the wind never stops. It has been blowing for as long as the sun has shone, a permanent gale of particles sweeping out through the solar system, washing over every planet, flowing past us at this very moment, and every moment, in a stream that has no end. The reach of this wind is almost beyond imagining. It does not simply trickle out to the nearest planets and stop. It blows outward past all of them, past the orbits of the giant outer worlds, past the cold and distant edges of the planetary realm, carving out an enormous bubble in the surrounding interstellar gas, a vast cavity, blown by the sun's breath, inside which the entire solar system sits. This bubble is called the heliosphere, and it is the true domain of the sun, the full extent of its physical reach. Every planet, every moon, every comet we know orbits deep inside it. Its boundary, where the solar wind finally grows too weak to push back the thin gas between the stars, lies almost unfathomably far away, so far that the fastest spacecraft humanity has ever launched, the Voyager probes, traveled outward for decades before they finally crossed it and passed, for the first time, beyond the sun's wind and into true interstellar space. We live, all of us, our whole lives, inside the exhalation of our star. That bubble is not merely a curiosity of where the sun's reach happens to end. It is a shelter. The wider galaxy is filled with cosmic rays, particles flung out by distant violent events, racing through interstellar space at close to the speed of light, and the heliosphere, the sun's outblown bubble, holds a great many of them at bay, deflecting them before they can reach the worlds inside. The same silent wind that blows past us unheard is also, quietly, standing guard. The sun does not only light and warm its planets, it wraps them in a vast, invisible, soundless cocoon of its own making. And here, once again, is the silence. This is a wind, a genuine, ceaseless flow of matter, blowing past us at hundreds of kilometers a second, strong enough to carve a bubble light hours across in the gas between the stars. On Earth, a wind is something we hear constantly. It sighs in the trees, it whistles past corners, it roars in a storm. The solar wind, vastly faster and vastly vaster than any wind on Earth, makes no sound whatsoever. And the reason is the one we have met again and again. The wind itself is a near perfect vacuum. For all its speed and all its reach, it is so thin, its particles so few and so far apart, that it cannot carry a sound any more than the empty space it blows through can. It is a gale by every measure except density, and density is the one measure sound depends on. So it streams past us, silent and unfelt, a perpetual hurricane of the sun that no ear could ever register, blowing through us as quietly as it blows through the dark. There is a fitting end to Parker's story, and it belongs in this account because it is so rare. Decades after his rejected paper, after the solar wind had become one of the foundations of how we understand the sun, a great spacecraft was built to fly closer to the sun than anything had ever gone before, to plunge again and again through the outermost reaches of the corona, into the very place where the wind is born, to measure at last, from the inside, the thing Parker had predicted from his desk. It was named the Parker Solar Probe in his honor, and in doing so it became the first spacecraft NASA had ever named after a living person. When it launched, in 2018, Eugene Parker was there to watch it go, an old man in his 90s, seeing the vindication of an idea the experts had once dismissed, now carried on a vessel bearing his own name toward the star he had spent his life trying to understand. He lived a few years longer, long enough to see it reach the sun, and then he was gone. The wind he discovered is still blowing, of course. It always will be, for as long as the sun endures. But Parker's wind does not blow through an empty solar system. It blows against worlds, and some of those worlds are not defenseless. As that river of charged particles races outward and reaches the Earth, it meets something invisible waiting for it, a shield thrown up by our own planet. And the encounter between the silent wind and the silent shield produces some of the most beautiful sights in all of nature, painted across the polar skies in perfect quiet. What that shield is, how it turns the solar wind aside, and why its handiwork glows without a sound, is what we follow now. The shield is magnetism. The Earth is, among everything else it is, a giant magnet, and that fact, which makes a compass needle swing obediently to the north, turns out to be one of the quiet conditions of our survival. Deep inside the planet, far below the rocky crust and mantle, lies a core of molten iron, and that liquid metal is in constant motion, churning and circulating as the Earth turns and as heat rises from the center. Moving molten metal generates magnetism, And so this great internal churn makes the whole planet into a magnet, throwing out a magnetic field that does not stop at the surface but reaches far up and out, thousands upon thousands of kilometers into space, surrounding the Earth in an invisible magnetic domain. That domain is called the magnetosphere, and it is the shield that meets the solar wind. When the wind from the sun comes racing in and strikes this magnetic shield, it does not punch through. The field deflects it. The charged particles of the solar wind, those flung out protons and electrons, cannot easily cross magnetic field lines. They are caught and turned, guided away around the planet rather than into it. The bulk of the wind sweeps past the Earth the way a fast river divides and flows around a boulder, slipping by on either side and closing again behind, leaving the rock untouched in the middle of the rush. We sit behind the boulder, sheltered in the magnetic lee of our own planet, while the gale of the sun streams past on every side. The encounter gives the magnetosphere a distinctive and telling shape. On the side facing the sun, the relentless pressure of the wind squashes the magnetic field inward, compressing it. On the side facing away, the field is drawn out into an immensely long tail, streaming downwind for a great distance like the wake behind a boat or the tail behind a comet. The Earth's magnetic shelter is not a neat sphere but a teardrop, blunt and compressed on the sunward face, trailing far out into the dark on the night side. The boundary where the winds push and the field's resistance come into balance shifts and flexes as the wind gusts and eases, breathing in and out with the moods of the sun, and all of this jostling of invisible forces, this constant give and take between a planet and a star across the vacuum, happens without the faintest sound. It is worth pausing on how much we owe to this invisible arrangement, because the alternative is written plainly on a neighboring world. Mars is a smaller planet, and long ago its molten core cooled and slowed, and its global magnetic field faded away to almost nothing. Stripped of that shield, Mars was left exposed to the full force of the solar wind, and over the ages the wind did to its atmosphere exactly what an unopposed wind does. It wore it away, peeling off the lighter gases and carrying them off into space, until the once thicker air of Mars was thinned to the cold, sparse wisp it is today. The Earth, holding on to its churning iron core and the magnetic shield it generates, kept its atmosphere, and its oceans, and everything that depends on them. The difference between a living world and a barren one may rest, in part, on whether a planet can throw up an invisible, silent magnetic wall against the wind of its star. But the shield is not perfect, and where it lets the wind in, it produces something extraordinary. Near the poles, the magnetic field lines bend down toward the planet, dipping in toward the surface, and along those lines, some of the solar wind's charged particles are funneled down out of space and into the top of the atmosphere. There, perhaps 100 kilometers and more above the ground, they crash into the atoms and molecules of the thin upper air, oxygen, nitrogen, and slam into them hard enough to knock them into an excited, energized state. And when those atoms settle back to rest, they release the energy they were given in the only way they can, as light. Oxygen, struck this way, glows in greens and deep reds. Nitrogen lends its blues and purples. The result is the aurora, the great shimmering curtains of color that hang and ripple over the polar skies, the northern and southern lights, folding and brightening and fading in vast silent sheets across the dark. The very shapes of those curtains are meaningful. The rays and folds trace the invisible magnetic field lines themselves, the particles sliding down them like beads on wires, so that the aurora is, in effect, the Earth's magnetic field drawing its own portrait in light, sketching in glowing color a structure that is otherwise entirely unseen, and silent is exactly the word. Here is one of the most spectacular displays in all of nature. Whole skies set glowing and rippling with colored light, the visible signature of the sun's wind crashing into the Earth's air, an event of genuinely planetary scale playing out overhead, and it makes no sound. The curtains shift and surge in complete quiet, light pouring across the sky without the faintest accompanying whisper, because the glow is borne far too high up, in air far too thin, for any sound it might make to carry down to the ground below. People who have stood beneath intense displays have sometimes reported faint sounds, a soft crackle or hiss, and for a long time this was dismissed as imagination. The best current understanding is that such sounds, when they are real, come from subtle electrical effects very close to the ground, near the listener, and not from the lights themselves, which hang silently in the high, thin air kilometers above. The display overhead is, and always will be, a thing of pure light. The wind strikes the shield, the sky catches fire with color, and the whole magnificent collision unfolds in the same deep silence as everything else out here. So the pattern holds once more and grows richer. The energy of the solar wind is not lost when it meets the Earth. It is transformed, turned aside, channeled, and in part converted into one of the loveliest sights the sky can offer. But the transformation is into light, never into sound. The universe, given the most violent raw materials imaginable, keeps choosing to express itself in ways our ears can never reach, in motion, in fields, in radiance. The aurora is the wind made visible. It is never the wind made audible. The gentleness of an ordinary night's display can be deceptive, though, because the same encounter has another face. When a great eruption from the sun, one of those coronal mass ejections, a mountain of plasma flung off the corona, strikes the magnetosphere head-on, the whole shield shudders and convulses, and a geomagnetic storm breaks across the planet. The aurorae flare and spread far from their usual polar haunts, sometimes reaching down toward the middle latitudes, where they are almost never seen. The most powerful such storm on record struck in 1859, after the astronomer Richard Carrington watched an exceptionally bright flare erupt on the sun's face. The storm that followed lit aurorae so far south that people read newspapers by their glow in the small hours, and sent currents surging through the young telegraph network so strongly that lines sparked and operators received shocks. Were a storm of that size to strike today, with our world wrapped in power grids and satellites and buried cables, the disruption could be severe. And yet even that, a planet-wide electrical convulsion, currents racing through the air and the ground, skies ablaze from the poles to the tropics, would arrive, like the gentlest aurora, in complete silence. The storm is electric and magnetic and luminous. It is never, anywhere, a sound. This drama of wind and shield and glowing sky plays out at every world that carries a magnetic field, and the Earth's is far from the grandest. Our magnetosphere is a respectable shelter, but it is modest beside what some other planets command. There is one world in the solar system whose magnetic domain is so vast, so powerful, and so crowded with trapped and racing particles that it dwarfs our own almost beyond comparison, a magnetic empire so large that, if our eyes could see it in the night sky, it would loom there larger than the moon. To see how grand and how silent a planetary magnetic field can become, we turn now to the giant of the solar system. Jupiter is a world built on a scale that makes the Earth seem like a pebble. More than 1,000 Earths could be packed inside it. It is not a planet of rock and soil, but a vast ball of gas and liquid with no solid surface to stand on, spinning so fast that despite its enormous size, a single day there lasts only about 10 hours. And deep within that spinning giant lies the engine of the largest magnetic field of any planet in the solar system. The source of Jupiter's magnetism is not a core of molten iron, as it is on Earth, but something stranger. Press down through Jupiter's outer layers, and the pressure mounts to almost inconceivable levels, and under that pressure hydrogen, ordinarily the lightest and most insubstantial of gases, is squeezed into an exotic state in which it behaves like a liquid metal, able to conduct electricity. An immense ocean of this metallic hydrogen churns deep inside the planet, and as Jupiter whirls rapidly on its axis, that churning, conducting fluid generates a magnetic field of staggering power, far stronger than the Earth's, and reaching vastly further out into space. The result is the magnetosphere of Jupiter, and it is one of the largest single structures in the entire solar system. It balloons out from the planet across millions of kilometers, and on the side, facing away from the sun, it is drawn into a magnetic tail so long that it reaches outward past the orbit of Saturn, the next giant planet beyond it. The numbers are hard to feel, so here is a way to picture it. If this enormous magnetic domain glowed with a light our eyes could see, it would hang in our night sky larger than the full moon, a vast, luminous bubble wrapped around a point of planet. The Earth's teardrop shelter is a modest thing beside this. Jupiter rules a magnetic empire, and it rules it across a gulf of space that dwarfs the planet at its heart. That empire is a fierce and dangerous place. The same magnetic field that wraps around Jupiter also traps charged particles and whips them up to tremendous energies, holding them in belts of radiation so intense that they would be swiftly lethal to any unshielded human being, and severely test even the most heavily armored spacecraft. The probes we have sent to study Jupiter up close must be built to survive a bombardment far worse than anything near the Earth, threading their paths to limit how long they spend in the most savage zones. Around this giant, the invisible field is not a gentle shelter, but a roaring, particle-filled furnace of magnetism. And the magnetosphere is fed from within the Jovian system itself by one of the most remarkable moons in the solar system. Io, the innermost of Jupiter's large moons, is the most volcanically active body we know of anywhere, its surface in constant eruption, flinging out sulfur and other material without pause. Much of that erupted matter is stripped away and swept up into Jupiter's magnetic field, where it spreads into a great donut-shaped ring of electrically charged gas encircling the planet and becomes part of the vast electrical circuit linking the moon to its giant world. The whole system crackles with energy, a planet and its moons bound together by invisible lines of force, currents flowing between them across the vacuum. That ceaseless electrical activity pours out across the spectrum, and one form of it carries an unexpectedly long way. Jupiter is, in fact, one of the brightest natural radio sources in the sky. Its magnetosphere, broadcasting bursts of radio waves so strong that, back in the 1950s, astronomers on Earth picked them up almost by accident, long before any spacecraft had gone near the planet, and were puzzled to find a planet shouting at them across the solar system. But notice what was crossing that distance to reach the radio dishes. Not sound, which could never have made the trip, but radio waves, which, as we are about to see, are simply another form of light. Jupiter's shout reached us because it traveled as light. Anything it might have tried to say in sound died at the edge of the planet. All of this magnetic violence has a visible crown. Like the Earth, Jupiter has aurorae where its field channels particles down into the upper atmosphere near the poles. But Jupiter's aurorae are on another scale entirely, permanent and colossal, glowing far more powerfully than our own, ovals of light wreathing the giant's poles, and fed both by the solar wind and by the material flung up from Io. They are among the most powerful auroral displays in the solar system, and they are, of course, completely silent, great rings of light burning at the top of a world, fed by a magnetic engine of monstrous power, and not one whisper of it crosses the vacuum to any listening ear. But Jupiter is also where we have to confront a particular confusion directly, because it is here that many people feel sure they have, at last, actually heard space. Spacecraft sent to Jupiter, such as the Juno probe now circling it, carry instruments designed to detect the electromagnetic and plasma activity around the planet, the radio emissions, the waves rippling through the charged gas of the magnetosphere. And the recordings these instruments produce have been released to the public as eerie, beautiful sounds. Whistles, howls, crackles, the famous moment when a spacecraft crosses the boundary where the solar wind crashes into Jupiter's magnetic field. People hear these and understandably conclude that Jupiter is roaring out there, that space is full of sound after all. It is essential to be clear about what these recordings actually are. They are not sound. No microphone could have captured them because there was no sound there for a microphone to catch. The magnetosphere of Jupiter is, like all of space, very nearly a vacuum, far too thin to carry an audible sound. What the instruments detected were electromagnetic signals and oscillations in the thin plasma, real, genuine measurements of the physics around the planet, but not pressure waves in air, and not anything a human ear could ever have heard directly. To turn that data into something we can listen to, scientists shift and translate it, taking the frequencies of the signals and converting them into the range of human hearing, so that a pattern in the data becomes a pattern in sound. The result is real, in the sense that it faithfully represents real measurements. But the sound itself was made by us, on Earth, as a way of perceiving the data. It is a translation, not a recording. Jupiter did not send us that howl. We built it, out of Jupiter's silence, so that our ears could take in what our eyes would otherwise have to read off a graph. This is worth holding on to, because it sits right at the heart of the question we are chasing. There is a profound difference between genuine sound, a pressure wave traveling through a real medium, the thing Boyle silenced in his jar, and the translations we make of signals that were never sound at all. Almost everything you may have heard described as the sound of some planet or probe or distant object belongs to the second kind. Data rendered as tone, the cosmos transcribed into something audible for our convenience. It is a wonderful tool, and we will come to how deeply we rely on it. But it is not the universe making a sound. It is us, lending the silent universe our voice. So Jupiter, for all its magnetic grandeur, its empire larger than the moon in our sky, its lethal radiation belts, its crackling circuits, and blazing aurorae, is, in the only sense that counts here, as silent as the empty space around it. The grandest planetary magnetic field we know of produces not a single sound that could ever reach us unaided. Everything it does in the language of fields and particles and light, never in the language of sound, which leaves us, finally, face to face with the obvious question that has been building beneath this entire investigation. If sound cannot cross the emptiness, if matter is too thin, almost everywhere, to carry it, then how do we know any of this at all? How does the light of Jupiter's aurorae, the glow of the sun, the shape of a magnetic field around a distant world, ever reach us across all that silent void? Something is clearly crossing the emptiness, and crossing it with perfect ease, carrying to us the entire visible universe. That something is light, and light obeys rules utterly unlike the rules of sound. To understand why the universe withholds its sound, and yet floods us with its light, why one messenger fails at the first gap, and another sails across billions of light years, we have to look closely at light itself. Light is a wave, like sound, and there the resemblance ends, in the single most important difference in this entire account. A sound wave is a disturbance of a medium. It needs air, or water, or some substance to ripple through, and without that substance, it cannot exist. A light wave is a disturbance of something else entirely, not of matter, but of the electric and magnetic fields that reach through all of space, present even where no matter is. And because of that, light needs no medium at all. It carries the very thing it travels through along with it. Where sound depends utterly on a crowd of particles to pass it along, light makes its own way across perfect emptiness, asking nothing of the void it crosses. The understanding of how this works came from one of the supreme achievements of 19th century science. The physicist James Clerk Maxwell, gathering together everything that was then known about electricity and magnetism, showed that the two were deeply intertwined, that a changing electric field gives rise to a magnetic field, and a changing magnetic field gives rise to an electric one. And he saw the astonishing consequence. If you set up such a disturbance, the changing electric field creates a magnetic field, which as it changes creates an electric field, which creates a magnetic field, on and on, the two forever regenerating each other and leapfrogging forward through space. The disturbance sustains itself as it goes. It is a wave that builds its own road ahead of it as it travels, and it needs no ground beneath. That self-propagating ripple of intertwined electric and magnetic fields, Maxwell realized, is light. There was a single moment of recognition that makes the achievement almost dizzying. When Maxwell worked out from his equations how fast such a self-sustaining wave ought to travel, the number that came out matched, with uncanny precision, the speed of light that experimenters had already measured by entirely separate means. The coincidence was too exact to be a coincidence. Light was not merely like an electromagnetic wave. Light was an electromagnetic wave, the same phenomenon as the invisible ripples of electricity and magnetism, arrived at from pure theory. In one stroke, the light of the sun and the forces in a magnet and the current in a wire were revealed to be expressions of a single underlying thing. For a long time, this was hard to accept, because everyone assumed that a wave simply had to be a wave in something. Sound waves are in air. Ocean waves are in water. Surely light waves had to be waves in some medium too. Physicists gave that supposed medium a name, the luminiferous ether, and imagined it as an invisible substance filling all of space, the stuff that light rippled through. The trouble was that no one could find it, and in 1887, two scientists, Albert Michelson and Edward Morley, performed an experiment of extraordinary precision designed to detect the Earth's motion through this ether by measuring tiny differences in the speed of light traveling in different directions. They found nothing. No matter which way they looked, light moved at exactly the same speed. There was no ether wind, no sign of the medium at all. The conclusion, forced and unwelcome, was that there was no ether. That light, alone among the waves people knew, needed no medium whatsoever. It really did travel through nothing. That single fact resolves the whole paradox at the center of this investigation. The universe is silent and yet not invisible, quiet and yet not dark. And the reason is simply that its two great messengers obey opposite rules. Sound is the language of matter, and dies the instant the matter runs out, which, in space, is almost immediately. Light is the language of the fields that fill even empty space, and crosses the void as though the emptiness were nothing at all. The same vacuum that strangles every sound at its source lets light pass through unhindered for billions upon billions of kilometers, without losing a single thing essential to it. Space is not a barrier to light. Space is the very thing light was made to cross. This is not to say light is untouched by its journey. Spread out from its source, it grows fainter with distance, thinning as it fans across an ever larger sphere, which is why the most distant galaxies are so dim that only our largest instruments can gather them. It can be absorbed by an intervening cloud, or bent by gravity, or stretched toward redder wavelengths by the expansion of space itself. But none of these is the death that overtakes sound. Light dimmed by distance is still light, still crossing, still arriving. Sound, denied its medium, does not merely weaken, it ceases to exist at all. That is the difference between a messenger that grows faint on a long road and one that has no road to travel. And light, it turns out, is far grander than the narrow band our eyes can see. The light we see, red through violet, the colors of the rainbow, is only a tiny slice of a vast family of electromagnetic waves, all of them the same kind of self-propagating ripple Maxwell described, differing only in the length of the wave. Stretch the wave out longer than visible light and you get, in order, infrared, then microwaves, then radio waves. Squeeze it shorter and you get ultraviolet, then X-rays, then gamma rays. From the longest radio wave to the shortest gamma ray, it is all one phenomenon, all light in the broad sense, all crossing the vacuum at the same enormous speed. Our eyes evolved to catch one small window of it, the window the sun happens to shine most brightly in. The universe pours out the entire spectrum, most of it forever invisible to us, all of it streaming across the silent dark. The speed at which it all travels is the fastest anything in the universe can go, about 300,000 kilometers every second, swift enough to circle the Earth several times in the space of a single heartbeat. Nothing outruns light. And because light needs no medium, because it is not laboriously passed from one particle to the next, but carries itself forward of its own accord, it can keep going for as long as there is space ahead of it. The light reaching your eye from a distant galaxy has been traveling, unbroken, for millions or billions of years, crossing an emptiness that no sound could have survived for an instant. To look out into space is therefore to look back into time. The further away a thing is, the older the light by which we see it, so that the night sky is a single image assembled from countless different moments in the past, all of them arriving now, all of them carried faithfully across the void. By the one messenger, the void cannot stop. The very oldest light of all has been traveling almost since the universe began, a faint afterglow, stretched and cooled by the ages, still arriving from every direction of the sky at once. We will return to it, because it carries a secret about sound that no one expected. This is why we know anything at all about the universe beyond our reach. Almost everything we have ever learned about the cosmos, from the nearest planet to the most distant galaxy, has come to us as light. We have never heard the universe. We have only ever seen it, and seen, for an astronomer, means far more than the eye alone can do. By building instruments sensitive to the invisible parts of the spectrum, we have learned to gather the light the universe sends in every form. Cold clouds of gas between the stars glow softly in radio waves and infrared. Warm dust shines in the infrared. Ordinary stars pour out their visible light, and the most violently hot and energetic places in the cosmos, gas heated to millions of degrees, the fierce environments around the most extreme objects, blaze in X-rays that no human eye could ever perceive. Each kind of light tells a different part of the story, and an astronomer reading all of them together can reconstruct, from light alone, the workings of objects unimaginably far away. The universe withholds its sound, but it broadcasts its light in every key at once, and we have slowly taught ourselves to read them all. So the deepest answer to why space is silent is not that the universe has nothing to express, it is that the universe expresses everything in a language our ears were never built to hear. The cosmos speaks fluently, constantly, across distances beyond imagining, but it speaks in light, not in sound. Sound is a local dialect, confined to the rare, dense pockets where matter gathers thickly enough to carry it. The inside of a star, the air of a living world. Light is the universal tongue, spoken everywhere, crossing everything, the medium by which the silent universe makes itself fully known. We live in a cosmos that is, to the eye, almost overwhelmingly loud, and to the ear, across nearly all of its vast extent, perfectly still. And yet we are creatures of sound. We are built to listen, to find meaning in what we hear, to feel the world through our ears as much as our eyes. It is no accident that we so badly want the universe to have a voice, that we are moved by the idea of the sounds of space even when we know they are translations. So having understood why the cosmos is silent, and why it nonetheless reaches us so richly in light, we come to a very human turn in the story, how we have taught ourselves to listen to a universe that does not speak our language, building instruments to catch what we cannot see, and learning, in a real and careful sense, to turn the silent light of the cosmos into something we can finally hear. We could not hear the universe, so we did the next best thing. We built ourselves new senses. The story of astronomy is, in large part, the story of extending the reach of our eyes, and then of going beyond eyes altogether, constructing instruments to gather the forms of light no eye can perceive. It began with a simple arrangement of glass lenses turned upward 4 centuries ago, which made the faint suddenly visible and the distant suddenly near. It has ended, for now, in great machines that perceive what we never could on our own. Each of these machines is, in effect, a new organ of perception. Vast metal dishes spread across deserts and mountaintops gather the radio light of the cosmos, the long invisible waves pouring from cold gas and spinning stars, and the active hearts of distant galaxies. Telescopes lofted above the atmosphere, into the clear vacuum of space, catch the X-rays and the ultraviolet and the infrared that our air blocks and our eyes cannot register. Where we were born able to see one narrow window of light, we have manufactured the ability to see across the whole spectrum, assembling from many kinds of invisible light, a far fuller picture of the universe than our unaided senses could ever have reached. We did not grow new ears to hear the silent cosmos. We grew new eyes, again and again, until almost no light in the universe could pass us by unseen. What those new eyes revealed was not merely a clearer version of the familiar sky, but whole categories of object no one had known were there. When radio astronomy opened up, it uncovered furiously energetic things invisible to ordinary telescopes, the blazing cores of distant galaxies, and dense spinning stars sweeping beams across space with the regularity of a lighthouse. When we lifted instruments above the atmosphere to catch X-rays, a still stranger universe appeared, gas heated to millions of degrees, and the searing environments surrounding the most extreme and collapsed objects in existence, regions that pour out almost all their light in X-rays, and almost none in the visible band our eyes can use. Each window we pried open showed us a cosmos busier and wilder than the last. The visible sky, it turned out, had been hiding most of the action, and only by building eyes for the invisible could we begin to see how much was truly going on. It is in that hot, violent X-ray universe, the one only our newest eyes can see, that the most surprising part of this story is waiting. And yet the longing to hear remained, and it turns out that longing is not merely sentimental. The human ear is an extraordinary instrument in its own right, astonishingly good at certain things the eye does poorly. The ear can pick a single shifting note out of a tangle of others, follow a rhythm, catch a faint and gradual change in pitch, detect a pattern unfolding in time that the eye, scanning a static image or a crowded graph, might easily miss. So scientists began to ask a clever question. If our data is just numbers, brightness here, energy there, a measurement changing across a stretch of sky, why not feed it to the ear instead of, or alongside, the eye? Why not turn the data into sound? This is the practice called sonification, and it is exactly what it sounds like, the systematic translation of data into audible tones. A measurement of brightness might be mapped onto loudness, so that brighter means louder. A position might be mapped onto pitch, so that higher in the image means higher in tone. Sweep across a picture of the sky from one side to the other, turning each feature into sound as you go. And an image becomes a passage of music, the bright stars ringing out as clear notes, the diffuse glow as a soft wash, the whole structure of the thing rendered as something you can close your eyes and listen to. It works just as naturally for data that unfolds over time. The slow flickering of a star's brightness, the rise and fall of a signal across hours or years, can be played as a melody, and the ear will often catch a rhythm or a stutter in it that the eye, staring at a jagged line on a chart, would struggle to pick out. The team behind the Chandra X-ray Observatory, the great space telescope that studies the universe's hottest and most violent light, has done exactly this with many of its images, led in the effort by the science visualizer Kimberly Arkand, turning pictures of star fields and exploded stars and the center of our galaxy into pieces of sound that anyone can hear. The reasons for doing this go well beyond novelty. For one thing, it opens the universe to people who cannot see it. A blind astronomer, or a blind member of the public, can apprehend through sound a structure that would otherwise be locked behind an image they cannot access, and more than one researcher has found real scientific patterns this way, hearing in the data something the eye had passed over. For another, it draws all of us closer to the cosmos, giving the distant and abstract a kind of immediate, felt presence. There is something profoundly moving about listening to the translated light of a dying star, or the rendered glow of the vast clouds at the center of the galaxy. It makes the universe feel, for a moment, near enough to touch, but honesty compels the same point that confronted us at Jupiter, only now stated as plainly as it can be. Every one of these is a translation. In all of it, the sonified images, the rendered data, the haunting tracks released as the sounds of this nebula or that galaxy, the universe supplied the light and the numbers, and we supplied the sound. There was never any sound out there to begin with. No microphone recorded these tracks, because no microphone could. There was nothing for one to catch. We took silence and information, and out of them we composed something audible, because we are creatures who understand the world through our ears, and wanted, badly, to hear. The voice in every one of these recordings is, when you trace it to its source, our own voice, lent to a universe that has none. None of this is dishonest, as long as we are clear about what it is. A map is not the territory, and a sonification is not a sound that traveled to us from the stars. It is an honest rendering of real measurements into a form the ear can hold. The trouble only comes when the distinction blurs, when a beautiful translation is mistaken for a recording, and people come away believing that the cosmos is full of audible voices waiting to be picked up. It is not, almost everywhere. And keeping that distinction sharp matters enormously here, because it is exactly the line that this story is about to cross. To see why the coming exception is so astonishing, you have to hold firmly in mind how rare and how strict the rule has been. Sound, real sound, simply does not happen out there. And so, after this long investigation, we seem to arrive at a clear and final verdict. Space is silent. It is silent because it is almost entirely empty, because sound needs a medium that almost nowhere exists, because every messenger that crosses the void crosses it as light and never as sound. The fury of stars, the gale of the solar wind, the magnetic empires of the planets, the collisions and eruptions and great slow motions of the cosmos, all of it unfolds without a whisper, and every sound we have ever attached to the heavens has been a translation, a kindness we performed for our own ears. The universe does not speak our language. We have only ever pretended, beautifully, that it does. That appears to be the end of the matter, except that it is not. Because the verdict, complete and well-founded as it sounds, contains a single crack, one extraordinary exception that the whole of modern astronomy did not see coming. After everything we have established, after building the entire case for a silent cosmos on the soundest physics, there turns out to be a place, out in the depths of space, where what we translated into sound was not light wearing the disguise of sound, and not numbers dressed up as tone. It was an actual sound, a real wave of pressure, moving through real matter, rippling outward exactly as the ringing rippled through the air around Boyle's bell, only on a scale, and at a depth, that nobody had ever imagined a sound could reach. The rule that space is silent, which we have spent this entire account proving, holds almost everywhere in the universe. Almost. And the one place it fails is so strange, and so vast, and so old, that it changes the whole meaning of the question we began with. The place is a galaxy cluster, and to understand how sound could possibly exist there, you first have to understand what a galaxy cluster is. We tend to think of galaxies as islands, each drifting alone through the dark, but galaxies gather, pulled together by gravity into great congregations, and a galaxy cluster is the largest such congregation there is. Hundreds or even thousands of galaxies bound together into a single colossal structure, the most massive gravitationally bound object in the entire universe. The particular one that matters here lies about 250 million light-years away, in the direction of the constellation Perseus, and it carries the catalog name Abell, 426. We call it, more simply, the Perseus cluster. Now here is the thing that everyone overlooks about a cluster, and that turns out to change everything. The galaxies are not the main event. Spread through the enormous volume between them, filling the cluster from edge to edge, is an immense quantity of gas, far more mass, in fact, than all the stars in all the cluster's galaxies put together. This gas is ferociously hot, heated to tens of millions of degrees, so hot that it glows not in visible light but in X-rays, which is why we could not properly see it until we built telescopes to catch that invisible light. And although this intracluster gas is, by any earthly standard, an almost perfect vacuum, thinner, even, than the thin gas between the stars, it is spread across a volume so unthinkably vast, millions of light-years from one side of the cluster to the other, that on those scales it adds up to a real and continuous medium. It is the loophole in everything we have established. Sound needs a medium. We have spent this whole account showing that space almost never provides one. And here, in the heart of a galaxy cluster, space finally does. Not a dense one, but one stretched across so gigantic a span that a wave can travel through it after all. In 2003, an astronomer named Andrew Fabian, working with colleagues at the University of Cambridge, turned the Chandra X-ray Observatory toward the Perseus cluster and looked, in the glow of that million-degree gas, with more care and for longer than anyone had before. And in the X-ray light of the hot gas, they found something faint and astonishing. Ripples, concentric ripples, vast curved ridges of slightly denser and slightly thinner gas, spreading outward from the center of the cluster in great rings, for all the world like the ripples that spread across the surface of a pond when a stone is dropped into it. Only here the pond was a galaxy cluster, and the ripples were each tens of thousands of light-years across. There is only one thing those ripples can be: a ripple of alternating compression and rarefaction, spreading outward through a gas, is the precise definition of a sound wave. It is exactly what Boyle's bell made in the air of his jar before he pumped the air away, regions where the medium is squeezed a little tighter, alternating with regions where it is pulled a little thinner, the pattern traveling outward through the medium. What Fabian and his colleagues had found, written across the hot gas of the Perseus cluster, was sound. Not a translation of light into sound, not data rendered as tone for our convenience. An actual, genuine physical sound wave, moving through an actual medium, out in the depths of intergalactic space. After everything, the universe had made a sound, and left its ripples standing in the gas for us to find. What was ringing the cluster like a bell? At the very center of Perseus sits a single great galaxy, catalogued as NGC 1275. And at the heart of that galaxy lurks a supermassive black hole, and it is the black hole that is the source of the sound. As it draws in surrounding matter, such a black hole drives enormous outbursts of energy, blowing colossal bubbles into the gas around it, shoving the intracluster medium outward in great heaves. Each heave, each push against the surrounding gas, sends a pressure wave rolling out across the cluster, exactly as a hand pushed sharply through water sends a wave spreading from it. The black hole, in effect, is beating against the gas of the cluster, and the cluster is ringing in response, the deepest, slowest drum in the known universe, struck over and over across millions of years. And then they worked out the note. From the spacing of the ripples and the speed at which sound travels through that hot gas, the pitch of the wave can be calculated. And the answer is one of the most extraordinary facts in all of astronomy. The note is a B-flat, but a B-flat 57 octaves below the middle C of a piano. That number is almost impossible to feel, so let it land slowly. Every octave down halves the frequency of a note. To go down 57 octaves is to have, and have, and have again, 57 times over, descending into a register unimaginably far below anything a human ear could ever register, a note something like 1,000,000 billion times lower than the lowest sound a person can hear. At so deep a pitch, a single oscillation of the wave, one complete cycle, the gap between one crest and the next, takes not a fraction of a second, but around 10 million years. This is the deepest note ever detected anywhere in the universe, a sound so low and so slow that the human species, in its entire existence, has not lasted long enough to hear a single full beat of it. Stop and take in what this means against everything that came before. Throughout this whole account, the rule has been absolute. Space is silent, sound cannot cross it, and every cosmic sound we possess is a translation we performed ourselves. That rule is true almost everywhere, almost. And the one place it breaks is here, in the hot gas of a galaxy cluster, where matter, though desperately thin, is spread across so vast a stretch that it becomes a medium after all, and where a black hole's slow heaving sets that medium ringing on a note too deep for any ear. The word almost, which we have leaned on since the very first sentence, finally shows its full meaning. Space is almost perfectly silent. The exception is a sound that has been sounding across 250 million light-years, for longer than there have been human beings to wonder about it. There is one more thing to be clear about, because it is the very point we have been building toward. When the Chandra team, the same scientists who turned so many cosmic images into sound, released the now famous sound of the Perseus cluster, they raised it by some 57 octaves to bring it up into the range our ears can reach, because at its true pitch, it is hopelessly, impossibly low. So in one sense, it is, like the others, a rendering. But it is a rendering of a fundamentally different kind, and the difference is the whole heart of this story. Every other sound of space begins with light, or with data, and ends with a sound that we invented. The sound of Perseus begins with a sound, a real pressure wave, a true acoustic ripple in a real medium, and all we did was lift it, unchanged in its essential nature, into a register where we could finally hear it. We did not give the Perseus cluster a voice. It already had one. We only tuned our ears to find it. And this deep, slow note is not a mere curiosity, a strange sound with nothing to do. It is doing something. The energy the black hole pumps into these pressure waves does not simply dissipate into nothing. It spreads outward through the cluster gas and warms it, gently and continuously, across the ages. This matters more than it might seem, because left to itself, the hot gas at the center of a cluster should steadily radiate its heat away, cool down, and collapse inward to form vast numbers of new stars. And yet, in clusters like Perseus, it does not, or not nearly as much as it should. The sound is part of the reason why. The black hole's impossibly deep note carries heat out into the surrounding gas and keeps it from cooling too far, regulating the whole enormous system. The sound, in other words, helps hold the cluster in balance, the same theme of balance we have met again and again, from the orbit of a planet to the poise of a star, now playing out on the grandest scale of all, and playing out, astonishingly, through sound. The deepest note in the universe is also, quietly, one of the instruments by which the largest structures in the universe keep their shape. So Andrew Fabian and his colleagues, reading the faint X-ray ripples in a cluster 250 million light-years away, found the thing this entire account had seemed to rule out: a real sound in space, the oldest and deepest ever known, a black hole singing a single endless note into the gas of a galaxy cluster and shaping that cluster as it sings. The silence of the universe is real, but it is not total. In the rare places grand enough, sound survives. And once we know that, a deeper question opens beneath this one. The note of Perseus is being sounded now, by a black hole active in our cosmic era. But if matter spread thinly across vast scales can carry sound, then we must ask whether there was ever a time when all of space was filled with matter dense enough and vast enough to ring, a time when the entire universe, and not merely one cluster within it, was a medium for sound. There was such a time. It was the beginning, and the sound it made is still, faintly, detectable across the whole sky, the oldest sound of all, and the last we have left to recover. To find a time when the whole universe could carry sound, we have to go back almost to the very beginning, to the first few 100,000 years after everything began, when the cosmos was nothing at all, like the vast cold emptiness it is today. In those earliest ages, the universe was unimaginably hot and unimaginably dense, and it was filled, everywhere and uniformly, with matter packed tight. There were no stars yet, no galaxies, no planets, no empty gulfs between them. There was only a seething, glowing fog spread evenly through all of space, a plasma of bare particles, the broken pieces of atoms, mixed through with an overwhelming flood of light, all of it crushed together at a density and a temperature that no place in the present universe even approaches. The whole cosmos, in other words, was a medium. Not almost a medium, not a medium in rare and special places, but a single continuous substance filling everything there was. And a universe that is everywhere, a medium is a universe that can carry sound, and it did. The mechanism was a tug of war between two opposing tendencies, and by now the shape of it should feel familiar. Gravity was at work, pulling the matter of the early universe together, trying to gather it into ever denser clumps. But that matter was thoroughly mixed with light, and the light pushed back, a fierce outward pressure of radiation resisting the inward pull of gravity. Where gravity squeezed a region tighter, the trapped light pushed it apart again. Where it sprang apart, gravity drew it back. The result was exactly what such a push and pull always produces in a medium: oscillation. The dense regions overshot and rebounded, again and again, and pressure waves went rippling outward through the primordial plasma in every direction. The young universe rang. It was not a quiet place settling slowly toward its future. It was a vast, resonating medium, filled edge to edge with sound, ringing with the pressure waves of its own matter sloshing against the pressure of its own light. These were sound waves in the fullest and most literal sense, the same compressions and rarefactions, the same physics, as the wave in Boyle's jar or the ripple in the Perseus cluster, but they raced through the searing, stiff plasma at an astonishing speed, more than half the speed of light. A sound moving at over half the speed of light, filling the entire universe at once. There has never been anything remotely like it since, and there never will be again. For a few 100,000 years, the cosmos was a single instrument, sounding one immense and complex chord through the whole of creation. Then it stopped, and the way it stopped is as important as the sound itself. As the universe expanded, it cooled, and after about 380,000 years it had cooled just enough for a profound change to occur. The bare particles, the loose nuclei and electrons, could at last join together into complete, neutral atoms. And the moment they did, the fog cleared. Until then, the dense plasma had been opaque, trapping the light within it, the matter and the light locked together and pushing against each other. Now, with the particles bound up into neutral atoms, the light was suddenly free. It stopped pushing on the matter and simply streamed away across the newly transparent universe, released to travel outward forever. That liberated light is the very same oldest light we spoke of earlier, the faint afterglow now arriving from every direction of the sky, the most ancient thing any telescope can see. And here is the crucial consequence. The instant the light broke free and stopped pushing, the force that had been driving the oscillations was gone. The sound, deprived of the pressure that sustained it, simply ceased. The waves stopped where they were. The pattern of compressions and rarefactions that had been rippling through the universe froze into place, like a wave on a pond, flash frozen in an instant into standing ridges of ice. The great primordial sound fell silent, but it did not vanish. It left its shape behind, printed into the matter and the light of the cosmos, and that frozen shape is still there, all around us, waiting to be read. We can read it in two places, and the first is the oldest light itself. The light that streamed free at that moment carries a perfect snapshot of the universe, exactly as it was when the sound stopped, and stamped into it are the frozen waves. Across the whole sky, that ancient light is very slightly warmer in some directions, and very slightly cooler in others, by tiny amounts, and the characteristic size of those warmer and cooler patches is nothing less than the frozen sound, the wavelength of the universe's own ringing, printed permanently on the sky. The oldest light in existence is, quite literally, a photograph of the oldest sound. When that ancient glow was first stumbled upon, in 1965, by two scientists who at first mistook it for interference in their antenna, and even suspected the droppings of nesting pigeons, no one yet understood the full depth of what it held. Only later, as instruments grew sharp enough to map the faint, warm, and cool patches in fine detail, did the frozen acoustic pattern emerge from it, and with it, a precise record of the sound the infant universe had made. The second place the frozen sound survives is grander still. It is written into the arrangement of the galaxies themselves. Each frozen ripple was a shell where matter had been gathered slightly more densely than elsewhere, and as the universe aged and stars and galaxies formed, they formed very slightly more readily in those denser shells. The consequence echoes down all the way to the present day. Across the entire observable universe, galaxies are very faintly more likely to be found at one particular distance from one another, a separation of around 500 million light-years, the frozen scale of that primordial sound, stretched out by the expansion of the cosmos over billions of years. It is a faint preference, far too subtle to see by looking at any handful of galaxies. But when astronomers surveyed huge numbers of them and measured the distances between them by the million, the signal emerged exactly as predicted. In 2005, a great survey of the sky, the Sloan Digital Sky Survey, working with the analysis led by the astronomer Daniel Eisenstein, found the frozen sound written into the spacing of galaxies across the universe, a standard ruler laid down in the first moments of creation and preserved in the architecture of everything since. What makes this more than a beautiful curiosity is that the frozen sound has become one of the most powerful measuring tools in all of science. The exact pitch of the primordial ringing, the precise size of those frozen waves, depends on what the early universe was made of and how it behaved. And so by reading the pattern with great care, cosmologists can weigh the universe's ingredients and trace the shape of space itself. The size of the warm and cool patches in the ancient light tells us that space is, to high precision, geometrically flat. The strength of the pattern reveals how much ordinary matter the cosmos holds, and how much of the unseen kind. The same standard ruler, measured at different distances and therefore at different ages of the universe, charts how the expansion of the cosmos has sped and slowed across billions of years. The first sound the universe ever made has turned out to be one of the most precise instruments we possess for measuring the universe at all. There is one more thread to draw in, briefly, because it completes the picture. Not all the matter in that early universe took part in the ringing. There is another kind of matter in the cosmos, the unseen, so-called dark matter, that does not feel the pressure of light at all, and so it did not slosh back and forth with the oscillations. It stayed where gravity put it, a silent scaffolding around which the ordinary matter rang. So the frozen pattern we read in the sky and in the galaxies is really the record of a duet, the ordinary matter sounding its pressure waves and the dark matter holding still beneath them, the ringing and the silent backbone together shaping where everything would eventually fall. The structure of the entire universe, the grand arrangement of galaxies across billions of light years, was scored in part by sound, the oldest sound there ever was. Step back and see what this does to the question we began with. We started by asking why space, being almost empty, is so silent, and we have followed that silence outward through stars and winds and worlds, only to discover that it has a floor beneath it, and that the floor is sound. The universe is silent now because it has grown old and cold and unthinkably thin, its matter pulled apart into islands separated by emptiness, too vast for any sound to cross. But it was not always so. It began as the very opposite of silent. It began full and dense and ringing, a single sound filling the whole of existence, moving at half the speed of light, sustained for a few 100,000 years, and then frozen forever into the fabric of everything. We do not live in a universe that has always been quiet. We live in the long, deepening silence that came after the first and greatest sound, a silence still inscribed, everywhere we look closely enough, with the frozen shape of that original note. And so the small word we have leaned on from the very first sentence finally gives up its full meaning. Space is almost silent. It is silent almost everywhere, and almost all of the time, but it was born ringing, and in the great clusters of galaxies it is ringing still, and the shape of its first sound is printed across the entire sky and woven through the arrangement of every galaxy in it. The silence is real, and it is nearly total, and it is also, in the deepest sense, a thing that came afterward. The universe began with a sound. What remains is the immense quiet it left behind, and the faint, indelible echo of the note that broke it. That is the answer this whole investigation was reaching for, and it only remains to gather it together and see, finally, what it tells us. So we can finally answer the question we began with, in full. Space is mostly empty, and we asked why. Then, it is not simply quiet, and the answer turns out to have two halves, each of which only makes sense in the light of the other. The first half is that space is quiet, profoundly, and almost everywhere, and for a reason as simple as it is absolute. Sound is a wave that needs a medium to carry it, and across nearly the whole vast extent of the cosmos there is no medium to be had. The stars blaze, the solar wind howls outward at hundreds of kilometers a second, the planets wheel, and the magnetic empires crackle, and the great eruptions bloom, and all of it unfolds in perfect silence, because the emptiness between things cannot pass a sound along. Everything that crosses that emptiness crosses it as light, never as sound. The universe is not quiet because nothing is happening. It is quiet because almost nothing is there to carry the happening to our ears. But the second half is the one that changes everything, and it lives entirely in the small word we have leaned on since the first sentence, almost. Space is almost empty, almost everywhere, almost all of the time, and where the almost fails, sound comes back, exactly as the physics always said it must. In the hot gas of a galaxy cluster, thin beyond earthly imagining but spread across millions of light years, a black hole sets the whole cluster ringing on a note 57 octaves below middle C, a real sound that has been sounding longer than our species has existed. And at the very beginning of everything, when the entire universe was dense enough to be a single continuous medium, all of space rang at once, a sound moving at half the speed of light, frozen at last into the sky and into the arrangement of every galaxy we can see. So the honest answer to whether space is quiet is this: it is almost perfectly silent now, but it began full of sound, and in the grandest structures that sound has never entirely died away. The silence is what came afterward. That answer also lets us hold, clearly and without confusion, the two very different things people mean when they speak of the sounds of space. Most of them, the haunting tracks of planets and probes and nebulae, are translations, and beautiful ones. Light and data rendered into tone by people who wanted to let us hear a universe that does not, in those cases, make a sound. They are our voice, generously lent. But a few of them are something else entirely. The note of the Perseus cluster, the frozen ringing of the early universe. These are not our inventions. They are genuine sounds, real pressure waves in real matter, that we have merely shifted into a register our ears can reach. The universe, in those rare places grand enough to carry it, truly does make a sound. We spent a long time assuming it never could, and we were almost right. Almost. It is worth returning, at the end, to the man in the Oxford room, because his small experiment turns out to contain the whole of it. When Robert Boyle suspended a ringing bell inside a glass globe and pumped away the air and watched the sound fade to nothing while the bell still visibly struck, he discovered the law that governs the silence of the entire cosmos. He had made, in a jar on a bench, a tiny patch of the condition that fills almost all of space, and inside it he had silenced a sound by taking away its medium. Nearly the whole universe is that emptied jar, scaled up beyond all reckoning, a bell forever striking in a vacuum, its motion real, its sound stillborn. Boyle could not have known how far his little globe reached. He had found, without leaving his bench, the reason the stars are silent, and yet Boyle's experiment holds the other half of the answer too, if we turn it around. He proved that silence is nothing but the absence of a medium, which means that silence is never absolute, never a property of the event itself, only ever a fact about what lies in between. Give the bell back its air, and it rings again. And that is precisely what the cosmos does, on a scale Boyle never imagined. In the rare places where it provides a medium, however thin, the bell rings once more. The Perseus cluster is Boyle's jar with the air let back in, a vast, tenuous medium spread across hundreds of millions of light years, through which a sound can travel after all. His emptied globe and that ringing cluster are the two ends of a single law, 3.5 centuries apart, and between them they hold the complete answer to why space is silent, and yet, in the end, not entirely so. There is a fitting symmetry in who completed the thought. It began with Boyle, listening to a bell fall silent in a jar, learning that sound needs something to carry it. It runs through Eugene Parker, deducing an entire silent wind pouring off the sun and being told he was wrong. And it arrives at Andrew Fabian and his colleagues, who studied the faint ripples in the X-ray glow of a distant cluster and recognized them, against every expectation, as a genuine sound in space, the deepest note ever found, sung by a black hole into the gas of a galaxy cluster across 10 million years for a single beat. From a glass globe on an Oxford bench to a galaxy cluster 250 million light-years away, it is the same question, pursued with the same patience, and answered at last. Not, is the universe silent, but where and why, and when is it not? And this changes what the silence itself means. We tend to hear silence as emptiness, as absence, even as a kind of death, the quiet of a place where nothing lives and nothing happens. But the silence of space is none of those things. It is the signature of a universe that has grown vast and thin and old. The sound of matter spread so far apart that stars and worlds and living things can exist in the gulfs between. The very emptiness that strangles every sound is the same emptiness that gives the cosmos room to hold galaxies, and gives a small wet planet the space to circle its star in peace. We are creatures of the long quiet that followed the great sound, living in the immense and patient silence the universe settled into once its first ringing had frozen into the sky. The silence is not nothing. It is the shape the universe takes when it has made room for everything that came after. And there is something quietly astonishing in the fact that the silence has been read at all. On a single small planet, in one thin pocket of air where sound still works, a species of restless, listening creatures looked out at a cosmos that seemed perfectly mute and refuse to accept the silence at face value. They worked out what sound is and why the stars withhold it. And then, not content even with that, they built instruments delicate enough to find the places where the rule breaks and recovered a sound that had been ringing, unheard, since before there were ears anywhere to hear it. The universe spent almost all of its history with no one to listen to it. Then, in one late and improbable corner, it grew listeners, and through them it began, faintly, to hear itself. The deepest note in creation went unheard for 10 billion years and more, and now it does not. That is no small thing for a universe to have managed. If you have enjoyed this journey into the silence of the universe and the rare, astonishing places where it breaks, a like or a subscribe helps us continue making them. So picture the cosmos one last way, and let it be the truest way. It is not a silent and empty hall, with nothing in it and nothing to hear. It is a struck bell. It was rung once, at the very beginning, with a force beyond all imagining, and the note it sounded did not stop. It only sank. Over the long ages, far below the floor of human hearing, too deep and too slow for any ear to catch, and it is sounding yet. We grew up inside that fading note and mistook it for silence, because we were listening at the wrong pitch. Only now, with instruments sharp enough to read the trembling of the most tenuous gas and the faint frozen ripples in the oldest light, have we begun to hear it for what it is. Not the absence of sound, but a sound too vast for us, ringing on across the whole of space and the whole of time. The universe is quiet, the way a great bell is quiet a long while after it is struck, still ringing, if you know how to listen. The universe still has plenty left to reveal, and we will be following it as it does.